Hello, and welcome to another episode of Geo Voices. A couple of days ago, I created a video about an application called Recast, which I am using practically every day. It's amazing, this little application, so I want to show you another of the ways that I use it for reading and studying, etc. So let me share my screen. Let's say, for example, that I just received a link with this paper, Gold Deposit in Metamorphic Belts, an overview, stunning problems, etc., etc. It's a very long report, and it looks very interesting. Before I will decide, okay, I'm going to spend half an hour or even more reading this paper or analyzing it using another AI tools, what I do is I just go here to this little icon here which says Recast. I click on Recast. I click on Recast it. I will not do it because I already done it. And in about, 3, 4, 5 minutes, I get an email telling me to go to this site. And when I go to this site, I have the full paper summarized down from 3,982 words down to almost 3 minutes. The podcast is like a conversation, and I got it to click here so you will hear it, okay, and we'll have a better idea and understanding how useful this thing is to get a first impression of the paper and decide if you want to read it or not.
Of the 3,900-word piece, Gold Deposits in Metamorphic Belts Overview of Current Understanding, Outstanding Problems, Future Research, and Exploration Significance from academia.edu. Let's listen in.
The article we are discussing today is about gold deposits in metamorphic belts. Metamorphic belts are complex regions where accretion or collision has increased or thickened the continental crust. Gold-rich deposits can form at all stages of orogen evolution, leading to a diverse array of gold deposit types.
This diversity also contributes to the ongoing debate regarding the origin of some deposit types, particularly those formed or remobilized during major compressional orogeny, the process that forms the final geometry of the hosting metamorphic belts.
One group of gold deposits that the article talks about is orogenic gold deposits, which form from subduction-related accretionary or collisional terrains. These are the most dominant type of gold deposit in metamorphic belts and include several giant and numerous world-class examples.
However, there are some unknowns about these deposits. We are unsure about their precise tectonic setting and age of mineralization, the source of ore fluids and metals, the architecture of hydrothermal systems, and the specific depositional mechanisms for gold.
So, as you can see, not only they make a very good summary of the report, they are also using technical terms, geological terms, in a perfect English. So this is amazing. Once you get this summary, you can share it by clicking here, and you can share it to Twitter, copy to the clipboard, or email it to some friends. Well, also, what I usually do when I get these summaries, these links, I create a little video just because when you read something with visuals, it stays longer in your memory. So I also use InVideo to create a 2-minute video about this report, and that is what I'm going to show you right now.
Fascinating world of geology. Today, I'm diving into the mysteries of gold deposits in metamorphic belts. These belts are complex geological formations, created by the collision and compression of Earth's tectonic plates. They host a variety of gold deposit types, each with unique characteristics and origins. Let's start with orogenic gold deposits. These are formed during the mountain building process and are the most common type found in metamorphic belts. They include some of the largest and most economically significant gold mines globally. But even though they're prevalent, questions remain about their formation. What's the source of the gold? How do the fluids transport it? What geological process is concentrated? Then there are other types of gold deposits associated with igneous intrusions and unusual metal compositions. These less common deposits present additional puzzles for geologists. Understanding these variations is crucial for developing accurate models for gold exploration and resource estimation. Despite decades of research, significant gaps remain in our understanding. One challenge is accurately classifying these deposits, as their characteristics can overlap and their formation processes are often intertwined. This ambiguity hinders the development of effective exploration strategies. Another key area for further investigation is the role of fluids in gold mineralization. How do fluids migrate through the Earth's crust, interact with rocks, and concentrate gold? Advanced geochemical and isotopic techniques are needed to trace fluid pathways and unravel the complex processes involved. In conclusion, more integrated and collaborative research efforts are essential. By combining detailed field observations, advanced analytical techniques, and numerical modeling, geologists can gain a more comprehensive understanding of gold deposits in metamorphic belts. This knowledge will not only benefit the mining industry, but also enhance our understanding of the Earth's geological processes and the formation of valuable mineral resources. Thanks for watching. Don't forget to like, subscribe, and hit the bell icon for more fascinating geological insights.